All right, guys, this is the last sample, like your homework problems number 13 and 14 tonight. Here we go. It says find the displacement and total distance traveled. They give you the acceleration machine. So we have to move from the acceleration to the velocity machine and then find the area under that velocity curve from 0 to 5. Here we go. To find the velocity machine, we have to take one antiderivative of the acceleration machine with respect to time. So in this problem, our acceleration is a constant. Do you guys recognize what that constant represents? Maybe not. That is the gravitational pull in feet per second squared. It's the acceleration of gravity here on Earth. Anyway, raise the power, divide by the power, and don't forget your constant. The constant of the antiderivative of the acceleration is the initial velocity. The initial velocity, which again, sometimes they write the initial velocity like this. Most often you'll see the initial velocity written like that, is 0. So we just plug in that 0. So our velocity machine is negative 32t. To find the displacement over the interval from 0 to 5, all we need to do is take the antiderivative of this velocity machine with respect to time and shove in our boundaries of integration. Here we go. Raise the power, divide by the power. Who cares about your constant? That constant would be the initial position, but it's not necessary to know where you started. All we're trying to do is track how far we are from that starting point, from 0 to 5. Clean it up a bit. Plug in your 5. There's the initial position, minus what you get when you plug in your 0. There's that initial position again, distribute your negative sign. So it really doesn't matter where this starts. So the displacement is whatever negative 16 times 5 is. So it's left of the original starting point. But when we're talking about gravity, it's lower than its original starting point. So this is a drop a coin off the Willis Tower problem, okay? The initial velocity for dropping something is 0, and the original position would be on the 113th floor. All right, now here's the setup to find the total distance traveled. The total distance traveled, or the TDT, is equal to the absolute value of the velocity machine from one t value to the next, all with respect to time. So we've got the velocity function. We don't have to go and reinvent that. Plotting this velocity function, negative 32, that is the slope of this linear curve, and negative 32t, what does that look like? Well, it has one of these, and boy, that's steep. So we're finding the area, good Lord, from 0 to 5, from 0 to 5. It appears as if all of this is down below the t-axis. So we need to negate that known negative area, and here we go. Negate the known negative area from 0 to 5. What do you think the answer is here? Pause the video and think, how are the total distance traveled and the displacement related. That's right. In this particular problem, they're exactly the same. I hope this is helpful, guys. That should get you through day one. I'm going to try to post videos of day 2 today so that you can start working on those things tomorrow. Stay healthy, everybody. Enjoy.